Okay, so I showed this. I showed the formula for sum yesterday. We're going to take a look at it one more time. It is almost the same as difference, but it's plus minus plus. Okay, I think if you say that enough, it just starts to click. But the reason we put these formulas on top of each other because the variables are the same. Okay, again, the only thing that changes are the first two signs. Changes to plus and minus. The last plus b squared is the same for both. So it's helpful to compare those two. We're going to go ahead and do an example that's not on the worksheet, but then we will do a couple that are. This one, again, is actually more complex than what's on the worksheet. So how do you know if it's the sum of... Yes. How do you know if it's the sum of cubes? Well, you're going to have a plus in between the two terms. And then a couple more things. You should be able to see that they contain cubes. So we know 27 and 8 are perfect cubes. And then look at the exponents. So the exponents need to be multiples of 3. Okay? Because when you take the cube root of that, it'll end up giving you a whole number. So 3, 6, and 9 are all multiples of 3. So it's very likely we will use the difference of cubes formula for that. However, again, on the worksheet, I believe everything is power of 3. But you can use it if it's 3, 6, 9, 12, whatever. Okay, so first step is just like yesterday. You're going to write out your formula. Since there's a plus sign here, it's a plus b, a squared minus ab plus b squared. Okay, and the second step is to... Yes. Second step is to take the cube root of each term just like we did before. The reason I'm doing this example is because you can have multiple variables, you can have multiple exponents. You basically just take the cube root of each component of that term. And somebody was asking yesterday, can your a term be negative? And the answer is yes, it can. Okay, you can take the cube root of a negative number and get something back. You can't take the square root of a negative, right? So for example, let's say I want to do, I don't know how to do cube root in here, I'll have to do to the 1/3 power. Okay, so let's just do negative 27 to the 1/3. All right, so we get a number back, but if we try to do the square root of negative 16, it doesn't work, right? So you can take cube root of a negative number, you just can't take the square root or the fourth root or any even root. So the cube root of negative 27 then is negative 3. Okay? And then like I said, you're going to take the cube root of each component of this expression. Cube root of x cubed is x. Cube root of y to the 6. Okay, so when you're taking the cube root of something that's not a cube, you just divide it. Okay, so what's 6 divided by 3? It's 2. So your power is y squared. That goes back to the fact, remember when we converted, if you do the cube root of something, it's the same as raising it to the 1/3 power. Well, if you do y to the 6 to the 1/3, that's 6 times 1/3. It's the same as dividing by 3. That's why you get a 2. Over here we have cube root of 8, which is 2, and the cube root of z to the 9th. Again, you can just divide. 9 over 3 is 3. So b is 2z cubed.
So when you're figuring out the exponent, it's just dividing, basically.
Yes, when you have a root, that's correct. Like if it was 2 and 4, you would just do 4 over 2 or whatever, 12 over 2. So here's your a, here's your b, and for the next step, we're just going to plug that right into the formula. A is going to go right there, and the b is going to be substituted. And remember, put it in parentheses, especially, the first parentheses doesn't matter, you can just plug it straight in. For these that have powers and whatnot, make sure to put it in parentheses. So I'm going to go ahead and write that out. I think it was so sloppy, I just deleted it yesterday. All right, so for a, I'm going to plug in negative 3xy squared. Whoops, wrong example.
It's a negative?
Yes, it is.
So on this one, it stays negative?
Yep, because cube root of negative 27 is negative 3. B is 2z cubed, and notice there's a plus there. So it's going to be plus 2z cubed. Again, we're doing the sum. See if I can move this over a little bit. I think I'm going to run out of room here. Okay, now let's do our second set of parentheses, see if we can fit everything in. Okay, so it's going to be a squared, just like before. But again, all of that's being squared. So I have to put it in parentheses, like that. And then it's plus AB. So it's going to be plus negative 3xy squared.
That was minus AB.
Oh, you're right. Thanks for pointing that out. I'm too focused on trying to fit everything on the same page. It's plus minus plus, correct. Minus AB, so it's minus A times 2z cubed. And I'm just going to have to write the rest below that. I don't have any room, so it's going to be plus b squared. We'll end it right there. So b squared would be 2z cubed squared, like that. Okay, so again, it's a plus b, a squared minus ab plus b squared. A plus b, a squared minus ab plus b squared. So notice you've got a double negative right here. So that's going to end up being positive. There's a lot going on, so we'll talk about each thing. So first of all, the first set of parentheses is going to stay the same. There's really no simplification to do. All right, we'll see. Okay, so we do have a negative 3xy squared squared. First, you're going to do negative 3 squared, which is actually positive 9.
After the one you're on, is that a plus sign?
That's minus. There you go. Okay, and then you have x squared, so an x squared is going to go down there. And then you have y squared squared, that is y to the fourth. Okay, so we do have a double negative here. It's minus ab, but a is negative, so it's going to end up being a plus. Okay, we've multiplied monomials before, plenty of times, so basically we're going to multiply the constants first. 3 times 2 is 6. Okay, and then, you know, the variables are different, right? So we can just write them out. I mean, it's going to be plus x, y squared, z cubed. All right, and then finally, this whole thing is being squared, b squared, so it's going to be 4z to the 6. I think I can fit that in one thing here. And that's it. Again, that's actually one of the more, that's much more complex than anything you'll see on the worksheet. But let's do one on the worksheet. Yes. We'll do one on the worksheet. Let me do one with the GCF. And I'll go ahead and just do number 5. 2a cubed plus 128. Okay, so obviously 2 is not a perfect cube, so we've got to somehow, you know, make it work. What we're going to do is pull out a GCF. They're both even, so we can pull a 2 out. Okay, and that leaves us with a cubed plus 64. So now we have 2 cubes. Fix that. Okay, so your a term, which I know there's already an a here, but your a term for your formula would be the cube root of a cubed. So a is a. Kind of crazy. And then your b term is just the cube root of your second term, which is 4. Okay, I'm going to go ahead and write the formula out right here. I made a mistake before because I did it on a separate page. So it's going to be a plus b, a squared minus ab plus b squared. So another way of remembering the formula is, you know, the first two signs will be different no matter what. For difference, it's minus plus. For sum, it's plus minus. And then again, the last term is always plus b squared. All right, so we're going to plug in a and b. A is just a, right? B is 4. And before I forget, we do need to pull this 2 down, right? If you pull the 2 down, it's going to carry all the way down. So there's going to be a 2 here on the end. All right, so it's just going to be a squared minus a times 4 plus 4 squared. Okay, final answer. Still have that 2 out front times a plus 4 times a squared minus, I want to put the constant first, 4a plus 16. And I forgot my parenthesis there. So there you have it.